All right, we are going to go on another lesson here. This is Unit 16, Probability and Data Management. And this is Lesson 8-19, Theoretical Probability. It is found in Jump Math Workbook, page 200. So we're going to look at theoretical probability. This is a one-pager lesson in the workbook. And so we're just going to have a go at it, have some fun. Again, I love probability and data management. I love probability because of its ties to games and chance and that sort of stuff. So number one, circle the numbers that mean 3 out of 5 or 3/5. So we're looking for equivalent things to 3/5. And the equivalent things to 3/5 would be not 35%. That would be 3 divided by 5 would be 60%. So we'll circle that one there. Okay. 3 out of 5. Yeah, that's the same. 30 out of 50. Those are equivalent fractions, which means so is 60 out of 100. Let's see. 5 out of 3. No, that's not the same. And that's not the same. That would be 7 over 9. That's not the same. That would be 6 over 10. Yep, that's the same. And 9 out of 15. 3 times 3 is 9. 5 times 3 is 15. That's the same. 9 out of 10. That's not the same. Okay, so those are the ones that are the same as 3/5. Now, what they're trying to get at is you can play with the fraction and you can convert the fraction into a decimal, which you can convert into a percentage. Okay, so that's the way we play with probability as fractions, decimals, percentages, and we can even have like equivalent fractions. So 3/5 is the same as 6/10 or 61/100 or anything in between there. Let's take a look at number 2. Express each probability as a fraction, a decimal, and a percentage. Probability of white coming up is 1 out of 4 possible outcomes. The percentage is 0.25, which is 25%. Go ahead. Well, I'll do the last one. Probability of any color. Okay. The probability of any color is 4 out of 4. Oh, wait. Is white a color? I guess not. Okay, so we better erase that. They got all tricky on me. White is all the colors, though. Okay. Probability, we're going to say that they mean red or yellow. So 3 out of 4, which is 0.75, which is 75%. We're going to think that they didn't mean white as a color. So go ahead and do B, probability of red, probability of white, probability of green, using this little thing here. Okay? Let's take a look at number 3. Circle the numbers that can express a probability. Now, if the top number is the chance that something that can happen and the bottom number is the total possible number of outcomes, that can be a probability. That 1 in 3, that's a probability. 40% is a probability. This one is not a probability. You can't have 3 chances when there's only 1 outcome. So anything that's greater than 100% can't exist. Okay, so that can't be a probability. 0.58 could be a probability. That's the same as 58%. Any fraction where the numerator is smaller than the denominator can be a possibility. And any time where the numerator is bigger can't be a possibility. Okay, that means any number that's greater than 1 as a decimal isn't allowable. Okay, And, when we're talking about ratios, as long as the first number is greater than the second number, that's gravy as well. Okay? You cannot have any negative probabilities. Okay? A probability is some number that's greater than 0. Okay? No number that's greater than 1. We already said that one. Okay? Can you have a probability of 1? Yes. A probability of 1 is 100 out of 100. That's a sure thing. That's 100%. Okay? Yeah, you can have decimals of percents. You can have fractions out of 1,000. Okay? That's good too. No, can't have any negative numbers. Okay? No, can't have anything greater than 100%. Let's see. Probability, all of these ones are good. Let's talk about this one here. 0. Can you have a probability of 0? Yes. 0 just means there's no chance something could happen. It's the same as, it's actually the opposite of a 1. 100% chance something will happen, 0% chance something will happen. Describe an event that has a probability of 100%. Something that is absolutely certain. Well, there is a saying that the only things that are certain in life are death and taxes. I don't know if that's true or not, but it's a saying. There's other things that are absolutely certain as well. So in human history, it's certain that the sun will rise tomorrow. In human history, it is certain that grass will grow in the summer. Of course, unless there's drought, whatever. 50%. This would be where there's a 1 in 2 chance that something can happen. So there's 2 possible outcomes. The one that I can think of is flip a coin. Or play a game where there's only 2 players, win or lose. Okay? What about 0% chance of something happening? I'm sure you can think of something that's got a 0% chance of happening. Let's take a look at the next one. The probability of rain is often given as a percent. For each prediction, write a fraction giving the probability that it will rain. Reduce your answer to the lowest terms. So again, a 60% chance of rain is equal to 60 over 100. Percent just means out of 100. 60 out of 100, if I reduce, is the same as 6 out of 10, which is the same as 3 out of 5. That's it. 35% chance of rain is 35 out of 100, which is equal to, let's go 5 by 5, 7/20. That's it. Okay, go ahead and do C on your own there. In baseball, a batting average is the ratio of the number of hits to the number of times a player has a turn at bat. Batting averages are decimals that can be changed to fractions out of 1,000. For example, a batting average of 0.427 means 427 out of 1,000. Means a player had 427 hits in 1,000 times at bat. And that is a really good batting average. Baseball is a tough sport. So let's check out the question part of it. Find the probability of a hit given a player's batting average. Reduce your answers to the lowest term. So our probability of a hit, remember batting average is out of 1,000 times at bat. 125 out of 1,000. We're going to reduce that one to divide by 25. It'll be 5 out of 40, which is 1 out of 8, if you can believe it. All right, so 300 out of 1,000. This one's easier to reduce. That's just 3 out of 10. Okay, I'll let you do these ones on your own. See if you can reduce those ones as well. Remember, they're out of 1,000. Which player is most likely to have a hit? Player A has a batting average of 0.315. Player B hits 3 out of 10 pitches. Player C hits 32% of pitches. They're asking us to make these equivalent to see if we can see which one is greater here. So batting average of 0.315, you could compare them as decimals, as fractions, even as percentages. I'm going to convert them to percentages just so we can compare them. So 0.315 is 31.5%. 3 out of 10 would be 30%. And 32% is 32%. So which one is most likely to have a hit? Player C has got the highest percentage, highest chance of hitting the ball, 32%. Okay? And you can compare B on your own. And that is the lesson. That is theoretical probability in a nutshell.